Okay.
Oh, there are people already on?
Yeah.
Wait, they started our faces.
Alright,
Do we want to do that?
Is there a way?
Don't we want to like share screen?
can I get rid of this notification?
No.
Is it?
Just you?
Yeah.
Is it on? Yeah, it's on.
Do we want to go live first before we share screen?
But we shouldn't show. I'm just getting rid of all this shit.
One of them was probably won't get that many business people here tonight.
Okay, I was about to say, it's on my base.
Are we sharing screen?
Is that?
Yes, this is true.
The announcement about the part 2 minutes of it.
Got it. Got it. Cool.
Is one thing I'm worried about? Consensus.
Gotham wants to. I mean, he does want to do it.
Like,
I would joke with that. I would joke with that.
I don't know if
Is it working? Dust and laptop. This moment.
Hey everyone. Can you sign in through the office over there? So we can just play our data. We'll be bringing around 10 minutes. Sign in.
We look literally tight. MLab selfie. Okay. We have to get in the corner. No. Oh wait, surrounding stuff. Are we starting at Berkeley time? Berkeley time. Oh yeah, Berkeley time. Yeah, no, we're excited. What's the expectation?
You salty?
Alright. You land a bait. We got a haze mount. That's the next step. Request our hazing or yeah. Doors are open though, right?
Yeah, doors are open.
we should.
Maybe we can do that project.
Because I feel like I don't understand consensus stuff.
Yeah, right. We're so ambitious.
I think we'll have
we underestimate the percentage of people actually.
It's funny, the most qualified person might be
in advance, they would see it, and they'd be like, oh, I'm gonna go. Like, when it comes to the date, still, I'm thinking, like, when it comes to the date, like, oh shit, something else came up. Like, this.
So you keep going. I was like, I'm coming in. I mean, well,
I'm not, but.
The back people are out the windows.
Damn. Bro, you're brutal. Brutal. Oh, dude. Welcome, everyone.
Do you just want to put like a tape and stuff on that?
Like MLab this way or something?
I have tape. I can get.
Why don't we just pop Will? Is this on? Is it on? Is it not on? Will, do you? I think I might have some of your stuff. I have two. I have a iPhone charger and I have a whatever that thing is called, charger. Microsoft.
Okay, that must be mine then. Yeah, I lost mine.
Yeah. Do you want me to give it to you now?
Sure. Yeah, we have 9 minutes.
If we're live streaming, we should record it too.
No, I think Automator does that, yeah.
How long are you expecting?
So about 30 minutes, and we'll have about 30 minutes for questions.
Let me go over that.
Oh,
yours? Yeah. Oh, thank you. Dude, I totally resonates with like. There's one seat open in the front.
No, what I'll do is I'd say it again, and then at 10 I'll say, alright, if you can't sign in,
I know, dude. Crazy. Oh, we're definitely gonna like Stack Overflow. Stack Overflow. Dang, it's I know it's getting there. This is awesome.
once in a stretch. This is fucking insane.
Yeah, I was like, look at this. I was like, no, it's fine. No, I know. Yeah, I should type it. That's true.
You want to turn it around, actually?
There we go.
Thanks for the back camera.
Dude, that is insane.
Look at this room. Can we just look at it through my screen and be like, what the fuck?
Damn, dude. Okay.
It's broadcast, but it's not projected.
Oh, shit. Where?
Oh, wait. I got it.
Oh.
What is this?
Oh.
That's it, bro.
Get that over.
How you people on this? This is,
Can you take this out? Take this out. Put it on desk, man. We don't need that.
yeah, we don't need audio. Well, actually, also, it's recording this mic, right?
Yeah. We can do it. Okay, yeah, I'll put it on the desk.
Fix that.
Alright, how's it going, buddy? Pretty good. You want to hang out here or you want to have your place? I don't care. Okay, you got my place. Alright.
Okay. Go back.
It's weather. It's like my son. Is that how you were speaking? Yeah.
Got 5 minutes.
Wait, guys, it's orange.
What?
What?
What? Was it blue before?
It's blue.
Here. Was it blue before? Yeah. Try unplugging and plugging it back in. The color might have messed the colors up.
Okay.
Yeah, it's blue now. Okay, that's weird.
Alright.
Because it could mess up the colors if I just
Do you want to
like.
ask them to sign in again?
If you want, yeah.
Hey, for you, those of you who just joined us, could you sign in over here? We're gonna start in like 3 minutes, but.
That's how you were on.
Yeah.
We
We just did it. We just did it.
You were part of it, remember?
No, not that one. We could only see ourselves. We should do one where we just
Hey.
ask. Where do I sign it?
Oh, that's.
No. It's the. So there's a link. There's a link.
Oh, you pointed here.
You can sign it right here on my laptop. Tough crowd. Wow. Alright, minutes. Got the computer. You Phil have to do that too. What's up? Phil, it's.
We should share it. We should reserve some chairs for ourselves. Ooh, Will wanted to put a couch right here.
Yeah.
Let's just stand on the table.
Alright. I don't think we're allowed to stand on the table.
Well, should we all stand? It's kind of awkward.
If your couch thing was onto something. We're just like loud now.
Well, is it though?
Alright, everybody out of the room.
Everyone just bring the couch to the front. First person to bring the couch over gets in.
Are we live?
Huh?
Are we still live? Actually, which microphone?
I already thought of that, but like, it's fine. That would be so funny.
They hear us joking up here?
Forget to unmute, then it's whatever. They can't hear us.
They're like, oh, wait, it's not muted.
It's not muted.
Hi guys.
Don't judge us.
I'm glad my voice is back.
I'm happy for you, man. That was pretty quick.
So, I just had to like not talk for like 2 hours.
It's because we were yelling over that fucking music monster.
Yeah.
Really yelling.
I should probably tell like few ways to
We have mic strings.
Yeah.
You know, that's so seductive and creepy. It's just you're like, who the fuck is this guy? It's okay. I'm so nervous right now.
Where do you stand?
Oh no,
Like, where are the speakers gonna stand?
Wait, what is it?
Can we like stand back here?
So we're also watching.
What?
I don't know, dude.
That's all. Okay. Alright. That's kind of weird. If you literally just be, then people are gonna be watching them watching us.
Oh shit.
Can they even see that? Because this is the main screen. We don't talk about that.
No, the main thing is this. It's this, yeah.
It's this screen, right? So then, like, we're streaming the people, but like we see that. Like,
Yeah.
If they wanted to, they
have to Ideally, we should have like taped the iPhone up there and retaped the whole thing or something.
What's this?
GoPro.
Yeah.
GoPro and a drone. We just have it hovering the entire time.
That'd be awesome. We could like pan around and stuff.
Wait.
That's not what you want.
So I don't know if I see it.
I mean,
I mean, I streamed this guy.
What's the one like?
Oh, we can't verify. Okay.
yeah.
Why does that validate there?
Yeah, I know.
ML at bio.
Hey, we're the.
You ready? We have issues with the Wi-Fi. The stream. I don't know if it's on this one. Can't verify on that one. Should we check?
Yeah, you can
Use
check.
another computer.
No, you can.
This should be fine.
You just can't. 1 second. Oh, fuck. Yeah, we're still connected.
Isn't it? Alright. Hey, Brent, you guys want to stand over there? Yeah. Just so you don't block the screen, I guess. Well, I just like sit down.
Are we gonna say their names?
Yeah.
No, I was
Order presentation.
Wait, can we clear the front here so that we can have some space here? Because
Should we stand up there?
wait, ask people to go a little bit back. Because I mean, I think we should at least have this. It is. For all to be here.
I think it's probably not.
Actually, it's fine. I think we're fine.
I don't really have to people coming in, but it's not.
People might be leaving. People might be leaving, but it's too full.
I think you start that.
Just start.
Yeah. You could say for those of you.
And like people like live streaming.
Yeah, and also like the patio sphere stuff.
Okay.
That's good too.
Hello, everyone. So for those of you who can't get a clear view or can't really fit in here, we do have a live stream up. If you go to the Facebook event page, you can click on the Hangouts link to join us digitally. All right. And for those of you who just got here, please take time to fill out the sign-in. It gives us a lot of helpful info to make our events better, to make this info session run better, and things like that. So let's take about another minute, and then we'll get started.
Yeah, cool. You ready? Yeah. Suspense. Suspense killing me.
Yeah, no.
Come get it.
What's machine learning? You gotta
Traditional paradigms are all about designing systems that accomplish the tasks no one else. Machine learning is about throwing magic at problems you barely solve.
Alright, you got it. Don't laugh at good.
Do you want to get started?
Alright, let's do it.
So, are we introducing ourselves first?
Yes. Yeah. Right. Hello. All right, we're gonna get started. So, just
Okay.
all right, guys. Cool. So welcome to Machine Learning at Berkeley's first Infosession of the year. My name is Gotham. This is Ted, Will, Piyush, and Brenton, and we sort of form the executive committee for MLab this semester. We have a link here again. If you're joining us now, please use it to sign in and give us valuable information. So the agenda for today is that we're going to start off with a high-level idea of what machine learning is. We'll dive into who we are as a club, what we do on campus, and also how you can contribute, how you can join our effort in expanding machine learning at Berkeley. So to start off, I'll pass it on to Will to, blow your guys' mind.
All right. That's some high expectation. So how many of you guys in this room know what machine learning is? Like, just raise your hands. All right, this is perfect. Okay, so I'm just going to briefly go through what I think the field is, and then show some applications that I think are pretty interesting. So traditional computing paradigms, you really have to design a system, know it inside and out, and really understand the problem you're trying to solve. Machine learning is kind of magical in that you don't have to have any intuition about the problem. What you have to have is good data. You have to have a good representation of the problem, and as soon as you have that, it can solve literally anything. So I'm going to go through a few areas that I think are actually pretty cool. So the first thing I want to talk about is pattern recognition, right? AI research for a long time has been about solving symbolic systems, which is like, you're playing BioShock and the AI decides whether or not it's going to shoot you. That's an if statement. That's a bunch of symbolic programming that you have to design by hand. But the cool thing about recent advances in machine learning is literally we just take data, label it, and then these algorithms are acting extremely efficiently. So I'm going to show you a really cool video that came out of Stanford that actually does video classification. So in every frame of this video, they're actually feeding through a neural network the actual classes, so you can actually see what the neural network thinks it is. And unlike traditional computing paradigms, instead of having ones or zeros for the classification, it actually gives you a probability over all of the classifications. So you got wheelchair basketball here, street ball. It's pretty intense. The fact it's recognizing all of this live in real time, and additionally, that the predictions are smooth, that from one frame to the next, it's still thinking the probability is high, is kind of amazing. You couldn't even imagine programming this from scratch, right? You have to describe, okay, what's an edge? Okay, what's a face? What's a basketball? It's completely ridiculous. And the neural network that does this is something like 19 layers deep. It's really, really, really elegant. So this is a little bit of pattern recognition. The next thing I think that's pretty cool about deep learning and machine learning at large is dimensionality reduction. So when you look at an image of this duck here, I like the duck, rubber ducks are great. When you look at that image, it's not just this one and done thing, it's actually a 16,000 dimensional vector, right? All of those pixels are different points, different elements of one vector. And to really kind of grok that, to have a program that can deal with that, it's kind of intractable, right? But when you look at this data set, you have one duck there, one duck there, one duck there. It's the intrinsic properties of it are just rotations, right? It's just moving from one frame to the next. And so there's these dimensionality reduction algorithms in machine learning, which are really, really cool, right? I can take that data set, move it to 2D, and it really just forms a circle, right? Because we're just rotating. But all that information is intrinsic, and I don't have to describe it myself. That's what's powerful about machine learning. So I'm going to show you the next thing here that I think is pretty cool is reinforcement learning. So for those of you who stopped by the booth today, we're playing this video. So last night, I recorded some footage of a project I'm working on with Machine Learning at Berkeley, actually, called OpenBrain, which is a massively asynchronous neurocomputation framework. I'll get into all the details later if you guys are interested afterwards. But this thing is learning based on rewards, right? And we can actually get some really fantastic results. I don't know if you guys have seen OpenAI and DeepMind solving all the Atari games, but if this thing loads, it'll be pretty interesting. Yeah, it's not good. Yeah, well, it's okay. We'll wait for it, whatever. So the intrinsic properties behind this are pretty simple, right? you have an agent and an environment. And all the agent knows is how well it's doing at that given time. So just a quick aside, this is actually the formation of a part of the neural network that's actually going to perform with the algorithm I'm talking about here. But all this algorithm has is just the inputs from the pixels, and it's actually learned to move around in this world in kind of an effective fashion. This is like 3 minutes of training. But what's so cool about this is I literally gave it nothing. I said, okay, this is how you're going to form your neurons. But as far as the world's described, as far as anything else is described, it's doing it by itself. It's learning how to move by itself, registering these intrinsic properties of the environment. I didn't code anything. So machine learning is extremely powerful, right? It's going to change the way we do computing forever. And it all starts right now, right? The field's blowing up. There's no other time to enter machine learning where you're going to have this much support, this much enthusiasm in the community. It's ridiculous. So reinforcement learning, really recommend. Come check it out. Talk to me afterwards on this one. The rest of this video involves this guy running to a cave and drowning. So we're not there yet. We're not there yet. So the last thing I want to talk about, something that's been really close to my heart this summer, is generation. So me, Philip, Kuznetsov, Max, Johansson, we've been working on a project. I don't know, have you guys ever heard of real-time, or sorry, not real-time, but artistic style transfer? Has anybody heard of this? Right, so we've been working on a real-time artistic style transfer project as a part of MLab. And this is a video of it rendering the first few minutes of The Wizard of Oz. And I just want to like take note here of how brilliant this is, right? We're putting in, I know, not the research, but like what's happening here is amazing, right? We're showing the neural network an image of Starry Night, and we're showing it an image of Wizard of Oz. And all it's doing is saying, okay, change this image until the neural network is fooled into believing it's Starry Night. So I'll just show you this video real quick. And that ad, look at that, learn data science right now. So the modulation you see in the back there is actually because the footage was kind of shitty. This is like the old school sepia tone Wizard of Oz video. But it turns out it actually kind of makes a cool effect. As she walks across the screen, she'll paint the image. And the loading buffer will pop up too. So. Pretty cool. Deep learning hasn't solved streaming, but we're getting there. So yeah, machine learning is like seriously diverse. It's really cool, and I'm just like so glad I had a chance to work with MLab. And it's a pretty interesting field. So I hope you guys will enjoy what we have in store. You can check all these videos out on the ML at Berkeley YouTube channel. We'll post them up afterwards. So yeah, cool. So that's machine learning in a nutshell. I'm gonna pass it over to Ted here to explain who we are.
So yeah, that was really great. I hope you guys enjoyed what Will showed you. And I guess now that brings it back to us. Why are we here? What is MLab, and how do we tie in with machine learning at Berkeley and machine learning as a field? So you can read the mission statement up there. I'm not going to repeat it, but in a nutshell, what we're trying to do is building a community around machine learning at UC Berkeley. We are currently the only club on campus that's focused on machine learning on the student side. And I think that the work we do, we really love machine learning. We love the people that are into it, and we really hope that we can involve you somehow. And beyond us, of course, there are other components in this machine learning ecosystem at UC Berkeley. As a freshman, you come in, maybe you've heard these buzzwords, you want to get involved. How do you do that? Well, there are these new data science connector courses. These are, Data 8, Data 88, all these really awesome courses that are coming up. Those are still being developed, however, and there's still a gap between those and more advanced machine learning data science AI courses. Those are, 188, 189, and even beyond graduate courses. And, when you come into Berkeley, even if you know for sure, I want to do that, it's still going to take 2-3 years before you have the prerequisite knowledge in order to take those courses. What do you do in the meantime? Right now, there isn't anything very structured. Of course, you could do courses on your own projects, but there's not that community of like-minded people, and that's something that we all really missed, we wish we had, and that's why we started this club together. And, once you get those classes, you have those skills. Great, you submitted your neural network. You got a 97% classification accuracy. Good for you. Now what? Between that and what goes on in the real world with real-world data and companies is very different. And that's not even to mention the huge gap between that and doing novel research. And so machine learning at Berkeley is trying to hit both of those gaps. If you're a learning student, you're interested, We'll give you events, we'll give you workshops that can really get you the insight you need to determine if machine learning is a good career path for you. And then on the other hand, if you have already taken these courses and you have the knowledge, we'll help you apply that knowledge to real-world problems that have an impact. So this is the team for this semester that will be leading machine learning at Berkeley. I think most of us are here right now, so take a good look. Come speak to us after. We don't bite. We'd love to meet you and see what you have to say. And overall, from a high level, machine learning at Berkeley is structured around 3 components. We have events. These are open events to everyone, not just MLab project members, but to students, the people at companies. And these workshops and events really span a wide variety of levels. We have last year, for example, very beginner intro machine learning workshops where we taught that in MATLAB, all the way to very advanced seminars from companies that were focused around neuroscience and computational models based on that. And then the larger focus of our club beyond educational events is actually projects. So getting your hands dirty, applying what you learned, figuring out new things, and really working on the edge of what we hope to be is the current frontier in machine learning. On the industry side, we work with companies. They give us real-world data on impactful projects that are challenging to them, challenging to us, and we partner together in a win-win situation. You as students, as team members, gain skills, you gain expertise, you gain experience working on these projects that are invaluable when you're seeking full-time data science or machine learning roles. And for the companies, it's a recruiting pipeline, but beyond that, they get real actionable solutions and models that they can use in production. And that's something I think that is really great, and it's nice to know that you're working on a problem no one else has approached before, and the work you do actually has a real impact. And I think nothing speaks that louder than our research projects, where you actually are literally on the edge, because this has not been done before. And the stuff you're working on, ranging from OpenBrain to our other projects, it really is new, and it really potentially has the impact to be submitted to conferences and really change the field. And I guess to kind of differentiate, projects is a very vague term. There are some key differences, though, depending on what you are, as a student, are interested in. Our industry projects are, one semester long. They're constrained. They're kind of structured around like a consulting-like project where the company is our clients. The team size is fairly fixed, around 4 to 8, with project managers, usually 2. And then you work with real data, real companies. However, research, because it is a more variable subject, it's not, progress in research isn't as linear, right? You can't just say, I'm going to complete this in 3 months and it's going to be done. So because of that, the team sizes are variable, the lengths are variable, and really the end goals of those are very different as well, depending on the project. And for our events, this is something that one of my favorite parts of MLab are going to be pretty common this semester. We'll try to host 1 to 2 per month, and really they're all for all levels of experience. We'll let you know beforehand through our Facebook page about what kind of prerequisites will be required to get a really good experience out of each event. Many of them will have no prerequisites necessary, but some might require that you have some prior knowledge of machine learning and machine learning concepts. Moving on now, I think I'll give it to Piyush to talk about our industry projects.
Cool. Thanks, Ted. So hi everyone. So my name is Piyush, and I'm VP of Industry, which means I'm going to handle and oversee most of the projects that work with companies and on the industry side. So what do? Well, in order to further our mission statement, like Ted touched on, we're going to be going to, on the industry side, we work with a lot of different companies.
You're muted.
How do you unmute machine learning? Machine learning, can you unmute yourself, please?
Yeah.